morning friends. As you are aware, in previous session we discussed some of the characteristics of normal distribution and what are those applications. I have already said that it is the most widely used distribution, and we have also seen how to convert a given variable into standardized value. So, let us work out couple of examples on standardized normal distribution. So, let us say x represent the time it takes to download an image file from the internet. So, x variable is time. Suppose x is normally distributed with mean of 18, which you can see here, and standard deviation of 5. So, this standard deviation of 5, right. Find probability that the download time for the file would be less than 18.6 seconds. Now, this is what we have to calculate. So, for this, first of all what you need to do is you just convert x value into z value. So, you know x is equal to x minus mu divided by sigma. So, x is known, which is 18.6. So, 18.6 minus 18 divided by sigma is 5, right. So, this is how you can calculate. This is z is equal to 0.12. Now, you have to see the area area under the curve where z is 0.12. So, we know that this z is standardized scale. So, this is z, this is 0, z is 0 and z is 0.12, which is towards right side of 0. Now, just by looking at this distribution itself, you can know answer that the answer would be more than 50%, because this area is 50%, isn't it, and we have to calculate more than that. So, this is a distribution wherein you have been given z scale and this is your original x variable. So, mean is this, and we have to calculate the probability of downloading the file in less than 18.6 seconds, right. So, now what we should do? We should look at z table, right, and we should see what is the area under curve when z is equal to 0.12. So, if you look at this table, in this table you have been given area from here, right, from middle of this distribution, not from minus infinity. Okay. So, z is equal to 0.12. So, this is 0.1 and 2 is this, right, isn't it. So, z is equal to, when z is 0.12, what is the area under curve? It is 0.0478, right. Now, this is the area which you have found from table, this area, isn't it, this area. Now, you have to add remaining 50% area in this. So, this is plus 0.5. So, this becomes 0.5478, isn't it. Now, if you had used the other table wherein you had area under the table from minus infinity to z value, then you would have directly got this answer. Let us look at that table as well. Yeah, this table, right, z is equal to 0.12, right. So, this is 0.1 and 2, just see this answer 0.5478, just once again. So, 0.1 and 2, right. So, this is the value 0.5478, which we have obtained from this table as well. Now, let us look at how to find probabilities when the z value is in upper tail. So, it has got two tails, right. So, we call this one as lower tail and this one as upper tail, right. So, where z values are positive, it is an upper tail, otherwise lower tail, right. So, we will take the same example. Suppose x is normally distributed with mean this and standard deviation 5. Find the probability that the image would be downloaded in more than 18.6 minutes. So, what we just calculated? We calculated how much time the image will take to download in less than 18.6. Now, it is more than 18.6. So, what was our answer? 0.5472. I think this was the answer, yeah, 0.5478. Now, if you want to know the answer, you can easily just do it like this, 1 minus this value. So, you will get this area, because this area is already known to us. This one is 0.54, this one is 0.5478, and this can be calculated just by subtracting from minus 1 from 1. So, this is what we have done it, right. So, probability that it will take more than 18.6 seconds would be 1 minus probability when z is less than or equal to 0.12. So, this is 0.544522, right. So, this is what was the solution in earlier case, and we calculated or we found out this area just by subtracting this area from 1. Okay. Let us take a situation where we want to find out probability between two values, not in upper tail. So, we will take the same example. Now, what is the probability that the image would be downloaded between 18 seconds and 18.6 seconds? It means more than 18 seconds, but less than 18.6 seconds. So, this is your distribution, this is your mean 18 and this is your 18.6, right. So, we want to find out this area. Okay. So, for this what you need to do? You need to calculate, first of all convert these 18 and 18.6 into z value, right. So, let us do it. So, when x is equal to 18, this is 0, when it is 18.6, this is 0.12. So, this is your x scale, this one, and this one is z scale, is not it. So, what is the area under this this particular region? So, area from 0 to z is equal to 0.12. So, look at one of the tables. So, 0 to 0.12. So, let us look at this is the I think right table, is not it. So, 0 to 0.12. So, 0 to 0.12 is right 0.0478, right. So, this is 0.0478. Now, if you wish, you can do it in this manner as well. You can have a table from minus infinity to z, wherein you will find that the total area would be 0.5478. Let us look at this. Okay, it is not there in next slide. So, if you look at a table wherein you have been given z value from minus infinity to some z value, right, you will get area under curve 0.5478. Since you know this area and you know this area, so subtract this area, then you will know this area, right. So, this is a very simple example. Now, we have to calculate probabilities in the lower tail. So, we have seen probability in upper tail, probabilities between any two points, and now let us look at probability in lower tail. So, we will take the same example. What is the probability that the time image will take to download between 17.4 to 18 seconds, more than 17.4, but less than 18 seconds. So, this is the area we have to calculate, right. So, first of all what we should do, convert these two values into z, right. So, we have already calculated z for this x is equal to 18. So, this was 0. For this what it would be, z is equal to x minus mu, right. So, 17 minus 4 minus 18 divided by 5. So, it would be some negative value, right, is not it. So, let us say this 0.6 by 0.5. So, minus 0.12 is the z value. Here you will get minus 0.12, right. Now, how to calculate this area? So, from 0 to minus 0.12. So, we know that this total area is 50%, this total is 50%. So, from this, from infinity to 0 area is 50%, from 0 to minus 0.12 this is the area. In fact, this area is from again minus infinity to 0.12, and if you subtract this value from this value, you will get remaining area. Keep in mind that the answer would always be more than 50% in upper tail, it will always be less than 50% in lower tail, and it would be now it can be any probability if it is between A and B, right. So, you can have a situation like this where your A value is towards left side of z is equal to 0, and your B value can be towards positive side, right. So, you can have a situation where z is equal to minus 1 and z is equal to minus 2. So, area in this would be somewhere like this. So, z is equal to 0, z is equal to minus 1, z is equal to minus 2. So, this area you can calculate. Okay. Now, so the answer to this question would be what? It is 0.0478, and this answer you can see over here as well in table, where z is equal to, what was the z value? Minus 0.12. So, minus 0.12, this is minus, this minus 0.1 and 2 is this 0.4522, 0.4522, and subtract 50, this is to be subtracted from 50% area, right. So, this is how you should get the answer. So, this is how you should get the answer to this question. Now, let us look at one more example on normal probability distribution. So, this is the normal density function. I have already told you that this z is nothing but, what is z? X minus mu by sigma, right. Let us look at this example. Pepzone sells auto parts and supplies including a popular multigrade motor oil. when the stock of this oil drops to 20 gallons, a replacement order is placed. The store manager is concerned that the sales are being lost due to stock outs while waiting for an order. Now, it has been determined that demand during replenishment lead time is normally distributed with mean of 15 gallons and standard deviation of 6 gallons. So, what is the concern here? Whenever you place the order and when you receive the order, so that time is known as lead time. So, there is a possibility of a customer not getting oil during this lead time due to stock out. So, the manager would like to know the probability of stock out. What is the probability of stock out when the oil is more than 20 gallon, right, or when the so in this case we need to find out that probability wherein the x value is more than 20. It is very similar to what we have seen in previous one of the examples. So, first of all convert x into normal distribution. So, this is how you should convert. So, z value is 0.83, right. So, find area under normal curve to the left of z, right. So, this is how you can look at table. So, what is the z value? Once again let us look at 0.83. So, this is how you can calculate area under the curve. So, z is equal to 0.8 and 3, right. So, just once again 0.8 and 0.03. So, it becomes 0.83. So, this is how you should calculate probabilities under curve when z is 0.83. So, this is 79.67. So, the area under standard normal curve to the right of z is equal to 0.83 is 1 minus 0.7967. This is the table value when z is equal to 0.83. When z is for z more than 0.3, it is 0.2033. So, probability of stock out is 20.33%, right. So, this is how we have answered our question. The graphical representation of the same. So, what we wanted, in fact we wanted this z for more than 0.83, right. So, this area is more than 0.83 and the table value we calculated from minus infinity to this area to this point, right, but we wanted this area, right. So, 1 minus 0.7967. Now, if the manager of PEP zone wants the probability of stock out to be no more than 0.05, here what is the probability of stock out? It is 20%, is not it, 20.33%. Now, the question is, if the manager of PEP zone wants the probability of stock out to be no more than 0.05, what should be the reorder point? Should reorder point be more than the previous one, or it would be less than that? So, let us calculate that value. So, what was the question? What is the probability that the stock out probability becomes 0.05. Okay. So, area under this curve is unity, we are interested in this area, right. This is 0.05. Now, find the z value that cuts off an area of 0.05 in the right tail of the standard normal distribution. So, you need to look at what is the z value when area is 0.9500. So, if you look at this, if you look at this table, now you don't look at the value of z for the time being, look at in this table and see where area is 0.9500. So, if you look at this, it is somewhere here, right, 1.64. What is the area at 1.64? It is 0.9495, and area at 1.65, it would be 0.9505. What we want? We want that value of z where area is this. Okay. So, we will convert. So, we will see that z value is nothing but you just take the average of these two, right. So, that would be 1.645, right. So, this is how you can calculate value of z just by looking at area. So, you can use normal distribution curve, normal distribution table for calculating area for a given value of z, and if you know the area, then you can get z value as well. So, this is how we got z value. So, x, now we want to convert this x value is this z value into x value. So, x is equal to mu plus z sigma, right. We know sigma as standard deviation is equal to 6. So, this x value becomes 25. So, the reorder point of 25 gallons will place the probability of stock out during lead time at it would be less than the previous case, right. So, what is the conclusion at the end of the day? So, if you keep reorder point of let us say 25 gallons. So, whenever you reorder this particular oil, you should reorder 25 of gallons of it, not the 21, otherwise there would be the probability of stock out higher than this. Now, this is just 5%, is not it? Earlier it was some 20 plus percentage, is not it? So, this is how you can convert z value into x value. So, what we will say, by raising the reorder point from 20 gallons to 25 gallons on hand, the probability of stock out decreased from 20% to 5%, and this is significant decrease in the chance that pipe zone will be out of stock and unable to meet customers demand during lead time. Now, let us look at normal approximation of binomial probabilities. We have seen in case of discrete distribution, we have used Poisson distribution instead of binomial distribution. Why? Why did we use Poisson distribution? Because in binomial distribution you have got very difficult calculations are very tedious. So, under certain conditions we could approximate Poisson distribution as binomial distribution. And what were those conditions? The n was n has to be large, it is equal to or more than 20, and p has to be very small, right, it is less than or equal to 0.05, right. So, similar to that, we can also approximate binomial distribution with normal distribution. So, rather than using binomial distribution, you can use normal distribution. When the number of trials n becomes large, evaluating binomial probabilities function by manually or with calculator is difficult. The normal probability distribution provides an easy to use approximation of binomial probabilities under this condition. So, when n is equal to more than 20, NP is equal to or greater than 5, and NP, this is NQ, right. So, NP greater than or equal to 5, NQ greater than or equal to 5, and N greater than 20. In this situation, you can always use normal distribution instead of binomial distribution. So, let me summarize what we did in this session. In this session, we have calculated different probabilities when whether the probabilities were under upper tail or lower tail or in between. You need to keep in mind that you should convert the given x value properly by using z formula into z value, and then you need to calculate area under the curve from z table carefully, and you need to be very sure when you have to subtract area from which remaining area, is not it. Sometimes you need to add area in 50% of the area, sometimes you need to subtract area from 50% of the area. Sometimes you may have a situation where you are finding area from left side to the 0 and area from right side to the 0, and then you are adding both the areas. Now, in all these circumstances, it is very necessary to add and subtract areas. So, with this, let me come to the end of this particular session. In next class, we will see how normal approximation or how normal distribution can be used to solve those questions which we can solve using binomial distributions, but in binomial distribution you will have to perform lots of calculations. So, thank you very much.